Welcome to the fourth module of our Certified Evervolt Installer Training Program. Now we're going to talk about basic battery safety and performance. Before we dive into the details, a few basic guidelines when dealing with lithium-ion or any concentrated form of energy. Do not install batteries near a heat source such as a furnace. Do not get the batteries wet. Do not apply strong impacts to a battery. If you find one does have impacts on it due to shipping and handling, please reach out to your Panasonic representative. And do not disassemble or modify the battery pack. This slide is repeated from the first module for emphasis. Again, as DNVGL noted in their battery performance scorecard, it is difficult to say that one battery chemistry is superior. Certain products and manufacturers have tried to differentiate themselves by calling their products inherently safe or immune to thermal runaway. The reality is that they are all susceptible to fire and the emission of plastic-related pollutants. When installing a residential energy storage system, it's important to think about planning for fire escape routes as well as potential impacts from vehicles or other equipment surrounding the area. As noted here, if you're going to install a residential energy storage system in the garage, you want to make sure that there is adequate space for parking a vehicle and that there is space for vehicle protection, such as bollards. If you're backing into the garage, you do not want to impact that battery module. If installing in other places inside the home, you'll want to make sure that they're not in habitable spaces, particularly places where you sleep or other living room areas, as this could potentially impact fire escape routes. You do not want to install a battery on the outside of a house underneath a window, because during a fire or disaster event, the windows can be used as an exit to the house. There are several certifications required to sell an energy storage system into the US market. The first of these is UL 1973, which applies to the battery module, in this case the DCB 105. Every DCB 105 undergoes this certification, which includes safety tests such as overcharging, imbalance charging, thermal cycling, impact resistance, and fire exposure tests, along with many others. The next test is UL 9540, which applies to the entire system, in this case Evervolt. It includes similar tests along with many others in addition to those contained in 1973. The two major safety features come into play with the BMS as well as physical safety measures in the system itself. The BMS is what is controlling the charge and discharge along with monitoring the temperature and other events within the battery module. Physical safety measures, many of which are proprietary to Panasonic that have been developed over many years, include physical barriers and structures between the battery cells themselves, along with several other safety features. All lithium-ion battery modules are considered Class 9 Hazmat material by the PHMSA, or the Pipeline and Hazardous Materials Safety Administration, which is a sub-agency of the Department of Transportation. Their basic requirement is that all Hazmat employees, so this would, in this case would be anybody handling or transporting the DCB 105 battery module, are required to be certified. There are several online training certification courses that should only cost a few $100s or less, and that require a few hours of time. And all employees handling these systems should undergo this training. There are certain labeling requirements for hazmat materials as well. These are the ones that you will see on the DCB 105 box when it arrives. It is important to note that if you are ever going to perform a warranty claim or warranty replacement, you'll want to reach out to your Panasonic representative in order to ensure that the correct labeling is applied and the correct and safe packaging is enforced. There are several safety features built into the DCB 105 for storing for an extended period of time that will prevent discharging completely. With that said, there are basic guidelines for storing a DCB 105 battery pack as shown here. If less than 1 year, it can be stored within a warehouse or climate-controlled environment, keeping it at room temperature. If it's being stored for more than a year, please reach out to your Panasonic representative, as we can provide guidance on how long it can be stored beyond 1 year based on your specific circumstances. Similar to your cell phone battery, the lithium-ion batteries in Evervolt will degrade over time. How fast they degrade depends on many different factors, including the charge and discharge rate, the depth of discharge, and the temperature. You'll see a sample chart on the right side of this slide that shows the state of charge and the degradation over the operational 10 years. You can see that as temperature increases, the batteries will degrade faster. Therefore, it is recommended to install Evervolt within a climate-controlled environment for maximum battery longevity. A common guarantee provided in the residential energy storage space refers to cycles. With Evervolt, we generally stay away from the term cycle because it does not account for battery degradation over time. Additionally, a cycle can be a discharge of 50% and then charge to full 100%, or it could also be a discharge of 100% charged fully to 100%. So cycles do not provide a clear understanding of how much energy is provided throughout that battery's lifetime. Unfortunately, a precise degradation curve is not able to be provided because there's different use cases. As mentioned previously, battery degradation can depend on many different factors, and each homeowner has some level of control over how they will have that battery perform. Therefore, you can see here, this is an example slide from an EV manufacturer showcasing that their theoretical degradation curve is the red trend line. However, in actual use, you'll see the blue dots are various real-world situations. For Evervolt, we will provide an energy throughput guarantee. And again, this is because cycle life is not a very useful metric to gauge battery health or warranty. As mentioned before, it does not account for battery degradation over time. An example calculation would be a 10 kilowatt hour battery pack that will deliver 10 kilowatt hours or close of energy during its beginning of life or on the first day of installation. However, on the last day or the last 1,000 cycles, the actual energy may be closer to 60 to 80% of that initial capacity. So what happens in between? So it's very difficult to determine how much energy a battery will deliver per cycle other than at the beginning of life. And this again is if we were to define a cycle as a full 100% discharge and charge. Project economics are driven by energy capacity or energy throughput. That's the exact metric that homeowners are used to paying on their utility bill. So the energy throughput, to summarize, is the total amount of energy a battery can be expected to store and deliver over its lifetime. In this slide, we're going to show an example of a manufacturer that's providing a cycle count but not an energy throughput. In this battery, they are saying it is a usable capacity of 10 kilowatt hours on day one and are providing a 10-year or 3,650 cycle warranty, whichever comes first. At the end of that warranty period, they're providing a performance guarantee of 70% of the initial capacity. So in order to get the energy throughput, a common calculation would be to take the 3,650 cycles that are guaranteed for that warranty, multiply it by the 10 kilowatt hours of the usable capacity to get the 36.5 megawatt hours of energy throughput. However, as previously noted, this does not take into account battery degradation. The next best thing that you could do is to take an approximate calculation, which would be a linear one, saying that the beginning of life capacity is 10 kilowatt hours, end of life would be 7 kilowatt hours based on that performance guarantee of 70%, to give you an average capacity of 8.5 kilowatt hours over that lifetime. If you take that 8.5 times the 3,650 cycles, you'll come to the conclusion of 31 megawatt hours of energy throughput. Again, this is just the best calculation that you could do given the information, and that is why we at Panasonic, we provide a specific energy throughput guarantee of 7.56 megawatt hours per DCB 105 battery pack, or 10 years, whichever comes first. We also provide the performance guarantee that 60% of the energy will be retained at the end of that warranty period. Again, the actual amount of energy retention at the end of the warranty period will depend on that site-specific conditions and how that homeowner uses that battery over the years, but 60% will be the minimum guaranteed. And that concludes our battery safety and performance section. We'll now move on to resources available for your Evervolt installation. Here we have Schip discharge values for Evervolt Standard and Evervolt Plus. This will also be available on our website as a download. We are currently in our pilot program phase where the homeowner will receive a $1,000 rebate direct from Panasonic for systems purchased by March 31st, 2020. The benefit to the installer and the homeowner, aside from the rebate, is that Panasonic will review each system designed to ensure compliance. We will also have at least one representative on site for the first installation to ensure a smooth and successful training and installation experience. There are several forms that the homeowner and installer must complete in order to participate in this pilot program, which you can find on our website shown here. We also have many other resources available on Panasonic's battery storage page, including the resources containing the specs and data sheets, brochures, and then more marketing materials geared towards homeowners explaining the benefits of battery storage and how it can be used in their home. For more information on how to purchase an Evervolt system, please reach out to your Panasonic regional sales manager. Depending on your territory, you'll see here. And that concludes Module 4. Please proceed to Module 5, where we'll wrap things up with installation best practices and a quick install guide.